what? Has order sets? Okay, so it helps with transactions to orders.
It can make it helps decision making in the ER. Like,
Okay.
I think Stevie was talking about the triaging system
Yeah,
that now
okay.
Apex has, so
Uh-huh.
support decision making.
Okay, yeah, so it has some decision support in there, right? But fundamentally, Apex was built to support transactions, right? To order, to have an encounter, right? That's really what it's built around, okay? Which is fine. So there's some decision support, as we mentioned, maybe triage in the ER. But really what we have is we have the virtual patient, the patient that I have in my head. Okay, when you curbside someone, right, you give a little blurb, I have a 47-year-old woman who's blah, 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 right? That's your virtual patient, that's who you're thinking about. You're not thinking about, here's a patient with these 7 lab orders and these 4 diagnoses and these 7 encounters, right? That's not what you tell someone when you're on a curbside. You say, hey, here's my virtual patient, what do you think? Okay? But the EHR doesn't help you get there. The EHR sort of change you to the data and the transactions, okay? It doesn't really get us where we want to stay, okay? Then there's research, which is way over on the other side. As I say, it should be tied together a little bit more tightly. And we've got systems that support this. So Encore is a big system that we have here that helps run clinical trials. CTSA has a bunch of systems on it. That's mostly what we focus on, is raw research data and clinical research transactions. Enrollment, recruitment, outcomes assessment, tracking adverse events, reporting to IRBs, right, all that kind of stuff, right? And again, nothing to do with medical knowledge whatsoever, right? That's separate. We want to tie those two things together, and for that we need medical logic, which is how do we relate knowledge to a particular patient, and then how do we support you making choices on that knowledge? Okay, so these are two very separate things. Right now, this doesn't really exist in our informatics systems, right? We have this, and we have this, and we have transactional systems, and this whole big thing in the middle, there's none of it. It's all in our head. It's all in our head. Okay? So huge amounts of opportunity. And tying this together is stuff that we really should pay more attention to. Systems that support our workflow, systems that are usable, that support the way we think without burdening the way we think, and that support us to work in teams. Okay? How many of you think Apex is usable? Has good usability? But it's the best of the craft. That's Michael Blum's term. It's the best of the craft. Okay? Cognitive support, does it really help us to think? I don't think so. I spend a lot of my time in clinic struggling with the EHR because it gets in my way. Okay, I have to remember which tab to tap on, and I'm not thinking about my patient. Okay, does it support teamwork? Somewhat, but it could do a lot better. Right? The way that I have Facebook, which I don't use, and work with people, that kind of thinking doesn't come into the EHR right now.
I'm trying to find out what it is that you're comparing Apex to. I mean, is it like it's an idea of a perfect model of an EHR, or is it like a particular example? Because I think compared to what we had before, it's pretty good, and I think it is relatively usable, and it does make things simpler at like my level, the medical student level.
Yeah, yeah.
But I feel like you have a much more stronger idea of what you'd like it to look like, and I know what that is. I mean,
Yeah.
I think you're at the car level, but we're still at the horse.
Yeah, no, I think that's true. I think that's really true. And I think my idea of a car probably isn't the right car. Okay, it's probably got it's a clunker, basically. Okay, but you know what? If we don't get there, we'll never figure out what a good car is, right? And so what happened is the government put in $16 billion, right, with the whole meaningful use thing to get everyone to use an electronic health record. And basically that money went straight to Epic, right, pretty much. And is that a good thing or a bad thing? Well, for many of us in the field, Epic sucks, okay? It was built on 1980s technology. It is client server, it is monolithic, it is just not how you build IT, it's not how you build software. And Apple would never have built an Epic, ever. Nobody in modern computer science would ever build something like Epic, okay? But we had to start somewhere. You're right, it's far better than paper. Okay, but the potential is huge. It's so much further beyond. Okay, so why aren't we there yet? Well, you have to, get your better horses before you get a car. But some other people think, no, why are we futzing with horses and carriages where we really should be going, the Google driverless car? So I think, you put your finger on it. It's like you don't ask the people on the front line, what kind of horse-drawn carriage you want, because it's hard to imagine the next step. And I think it's incumbent on those working in the field to give solutions that are more, that have some of these features. Okay, and right now I think the conditions are set to do that. EPIC covers about 40% of the US population. That's huge. EPIC is the system that Apex is, right? So yeah, they're really a market dominating product right now, but they're also stifling innovation because they're so big. But you've got startup companies and others that are really breaking into the field in a model that's very different. I'll get to that in a little bit, but it's a good question. Now, why is this important for you? You know, you're a medical student, you've got a lot of training and sleepless nights ahead of you. In the old days for research, you build your own database, you analyze your data, and you publish it. Right? That's the old model. Now you're going to need and want to bring together lots of data. Different types of data, right? New sensor data that other people might not have thought about, different sources, right? And you know what? If you're more innovative in this, you can bring together different kinds of data that other people aren't thinking about. You know what you can do, and you know how you can get at it in a realistic way and get a good proposal. I bet you'd score better than your colleagues. If you're asking the same old questions on the same old data, you know, I think you're leaving some opportunity behind, right? So think more broadly. What data do you want? How do you want to bring it together? What does that really mean? Is it possible? Sometimes it's impossible. You need analytic methods and models beyond statistics. You want to use a Markov model, which you can do now, of course. You want to do some of that unstructured data. You want to analyze large-scale Twitter data like stuff. Okay, who knows? I don't know, right? You need to identify and pursue and maintain wide collaborations, right? PIs, labs, health systems. There was an article very recently about funding for science. The New York Times article, did you read that one? So it's getting to where 20 to 30% of science funding is from private sources. Okay, that's companies, it's foundations, it's rich people, Warren Buffett. You know, you're going to need to work with far different people and different data sources and different models. And that has lots of implications for sharing data because they're technically far more savvy. They're used to, you know, IT and software the way we do it now in 2014 and not 1980s, which is where a lot of health IT is. Question in the back?
Do you think we'll ever get to the point, I'm not even going to ask about soon, if all the different epics and use are going to be able to talk to each other, like the epic here, the epics at Kaiser, not only for clinical research, but patient care?
So for patient care that already exists, we have Care Anywhere. So there is a little tab where we can get Kaiser data. Actually, if you know that. So we have patients who are admitted over at Alta Bates, there's a little tab, so that's done. It turns out that it's really hard to get epics to talk to each other. So in Pittsburgh some years ago, they bought Cerner for their electronic medical record system. They liked Cerner so much that they bought 3 versions of Cerner across the Pittsburgh medical campus, and none of them talk to each other. Okay, which is ridiculous. So right now, because of the meaningful use thing, all EHRs have to export in a certain format called Blue Button and Direct, which may or may not be going away. So basically, you've got a silo, but there's a small little pipe where data can come out of that silo. And that's starting to break the silos down. Starting to. So I think we're going to get there for clinical care slowly. For research, the bottom point here is to share data, there are 2 things. One is technical data sharing, whether you can do it technically, and the other one is policy, whether people are willing to share. And the willingness is still a question, especially for research. Kaiser is a good point. CTSI, we've been trying to share Kaiser data forever. There's a good reason they don't want to share it with us. You know? So you can have individual research projects with Kaiser Northern California. But on an institutional level, to say, share all that data, we're not there yet. We're not there yet. Okay, so the policy barriers are as high as the technical barriers. So they're both right now. But on sort of one-offs, it is happening. There are consortiums that are forming. You know, the Geisinger, Mayo, VA, Kaiser. You know, that's a collaborative shared data. That isn't quite getting too far. So I think we're trying to get there. You're going to see more and more pressure for that. So research requires informatics because you need to query across homegrown databases. Okay, we've got this electronic data warehouse that we're building. You know, whether we query within UCSF or across UCSF, it's informatics that gets us at analyzing meaningful information. So just one slide on this, right? Like, why the heck can't we just query across things? right? You probably ask yourself this, right? Why is it so hard? We can do it in banking, why can't we do it in health? So here's the story about banking, right? When you go to your ATM, you can do a transaction anywhere in the world, right? So why can't you get a little card anywhere in the world and get your medical record? Like, why not, right? So that would be your sort of, you know, a layperson's view. Why can't we do this, okay? Well, so here's the ATM thing. Okay, there are 10 standard tasks for you. Well, the transactions are pretty standard, right? Deposit, withdrawal, right? There's no ambiguities, it's just numbers. Okay, everybody know what 4.7 is, and the exchange rate to euros, that's defined. It's defined, right? Contrast this to healthcare. We're switching over to ICD-10, going from, I think, 19,000 codes in ICD-9 to 60,000 codes. SNOMED is at 1.5 million. Okay, I'm going to show you funny slides about things that are coded in ICD-10. The concepts are not well understood. That's what you guys are working on, right? I mean, many of us are working on things that aren't well characterized because we don't actually even really know what it is. I have a patient who has Bell's palsy. She had Bell's palsy on one side of the face last year in February, and last weekend she had Bell's palsy on the other side of the face. You know, I'd never heard of that before. So I looked up and I had to think about Sjogren's and neurosarcoid, and you know, I didn't know this bilateral recurrent facial palsy. So I emailed, you know, the peripheral nerve disorder clinic person here, and he said, I have no idea what the mechanism is for familial recurrent Bell's palsy. I have no idea. Okay? Yeah, we have lots of things we don't understand, and yet we need to name it. Okay? Complex varying tasks, right? Because there are many of us, there are nurses, there are pharmacists, there are doctors, and each customer is different. Right? Each patient is different, and we have many tellers. Each of us is kind of like a teller, right? So incredibly complex. And so understanding the complexity of healthcare tells you that it's not so simple as banking. In fact, it's incredibly, incredibly, incredibly hard. I actually think it's the most challenging domain for computer science. And computer scientists are now starting to get into health. That's why the NSF is funding a lot of work in this. That's why a lot of computer science departments are getting into health, because they realize it's like whatever it is, 15% of the GDP. And there's a lot of money to be had here, a lot of research questions that are very, very interesting. Okay, so what does this mean for you? For research, I think it's good for you to be a savvy informatics consumer. Know an informatics problem when you see one, which is not such an easy thing. Okay, know when it's an IT problem, when it's an informatics problem. Know what you can and cannot do. Okay, so that you really know what the research opportunities are. Know which collaborations you need for your grant. Okay, if you're designing an intervention, do you need a designer for your app? Do you need somebody who does user interaction? Do you need somebody who does machine learning? Do you need to know somebody who does natural language processing? What does that mean? Do you need to have somebody who does unstructured data? And what kind of skill set is that and who you work with? Okay, informatics plans are becoming increasingly important for successful grant proposals. Okay, if you're informatics naive, it's going to show. It will show. Okay, the study section still aren't very sophisticated in that, but it's getting to be there. If you're doing intervention research, whether it's an app or a decision support system or a knowledge management system, you need to know what technology can and cannot do. You need to know who you need to work with. How do humans and computers work together? It's a field called human interaction design. Evaluation is a critical issue. Okay, implementation sciences is really a whole branch of, sub-branch of evaluation. Okay. For clinical care, have you ever become a CIO, a CMIO or something like that? Know what's vaporware? I see lots of people buying things that are just complete vaporware. A lot of stuff you hear about, you know, this fantastic app or fantastic EHR or something, it's vaporware because it's just not feasible. Okay. So you need to have that radar, which is really hard to get. Right. Or if you really want to go this route, the field has lots of unsolved problems that require computational methods. Okay, so you can learn some fundamentals of informatics, get a master's or a PhD. There is a fellowship now in clinical informatics that's more application of technology, and that would be after you do residency, then it's a fellowship. And we don't have one here at UCSF. There is a new one starting at Stanford, and there'll be more. It's a brand new fellowship. Okay, and you want to be able to combine both biomedical domain knowledge stuff that you're acquiring now and combine it with some of these informatics tools and techniques. We need far more researchers in this area. There's starting to become dollars for training, like a KO1. NIH is starting to put money into this because they know this is really, really critical. We're not going to make those next advances if we don't have people who are better trained in informatics and in the biological domain. At a minimum, even if you ignore the first two, I think it's incumbent upon us as we go forward with this to be good citizens of science in a big data world. And I say this pretty heartfelt because, you know, we spend a lot of money generating data. And then we sit on it and we hoard it. And we publish on it little slice, right? And we get, and you know the NIH is worried about reproducibility, that all these things get out there and there's a report and then nobody can replicate it because nobody knows where all the data is. And then you can't reuse it. Okay, what a huge amount of waste, right? And now you've got big data, this idea that you can get all the data together and analyze for big patterns. You cannot do that if our data is siloed. And why is our data siloed? Partly because of technology, partly because of policy. Policy is our individual biases. It's policy at the institutional level. How many of you have a data set right now that you're working on? Who owns that data set? The PI owns it? Okay. Any others? Who owns it? Huh? The university? Okay. Who else?
The VA.
Okay, the VA.
I'm working on like previously published data in journals, so I guess if you were anyone's data at this point, you should publish it.
Okay, maybe if that's in the public domain. Yeah, possibly. Some people argue otherwise, but yes.
Red Cap has a lot of it.
Red Cap has a lot, but they wouldn't own it. They're just sort of the vessel for it, right? Who else would own your data? Does the NIH own it? The funder? No? How many of you are working with patient data? Clinical research, clinical trial data? Do the patients own any of that? No? Hmm? Do they? Not at all. They're little lab rats. Draw blood from them, do lots of data. Right now they don't. Should they own it? Who owns the EHR data? Should you own it as a patient? Should you own it as a doctor? Should UCSF own it? Well, you know what? We can't even figure out who owns the data. So it's really hard to talk about sharing. And all of us think, I work so hard on this data set, I can't share it because my career is going. Like, this is my K award, this is my R01. I can't share it. Okay? And that's how we work. And yet at the same time, we put all that together, maybe for rare diseases or even common diseases, maybe we'd learn things a little bit quicker. Okay? So how does physics work? Physics works by sharing all their data from the get-go. How does genomics work? Well, they share all their data from the get-go. Right? The whole GWAS thing, right? There's a lot more data sharing there, right? How do we do it in software? We actually open source a lot of stuff. We share a lot, and we all get together better. Do you think pharma shares? Pharma is sharing pre-competitive clinical data. Okay, pre-clinical data they're sharing. Because they know they need to share on those early signals because they're dying right now. Their whole business model is dying. When are we going to get to share? Okay, so helping create incentives and a culture that supports, rewards, and encourages data sharing, I think is absolutely critical. It's critical for us as a community. You know, that you need to get rewarded, you need to get promoted. If you share your data, you should get a citation or something that really means something to you. That when you go up for your grants, that you have shared your data should be a big plus. Not that you awarded it so you can get another grant. You know, so it's a culture change. I think we really need to get there. And it's because we now have tools that can make much better use of the data. And until we have that, we're not gonna get as far. So this is the big picture that we want to get to. Huge swaths of this landscape that's not being worked on, but it's huge opportunities. These are some of the things that are going on at BCSF. I teach a class in medical informatics for clinical research. The Clinical Research Fellowship, as I say, is not quite here yet. There's a bioinformatics PhD here, but not a medical informatics one. Center for Digital Health Sciences, run by Michael Blum, does a lot of sort of innovation type stuff with the Valley here. I do a lot of stuff in that space as well. I have a nonprofit that I co-founded called OpenM Health, and we're building an open architecture to get data sharing in mobile health and to support research using sensors and mobile devices. Great fun running a nonprofit startup. Institute for Computational Health Sciences, a new thing we're trying to build on campus. We're trying to hire, really top-notch people and really build a new academic focus in informatics on campus. It's pretty hard, pretty much every other university is trying to hire the same thing. But I just don't see how we could get ahead without something like this. But that's true of every single other university. So a huge area of opportunity, it's correct, way too big for any of us. But just think about how that might fit into your career, because I think the more you do that, the more you're going to be a step ahead. These are opportunities that they're just dangling up there. So the more you can take advantage of them, the better, I would say. So questions or further discussion?
You mentioned the recent government influx of money for EHRs around the country, and you said most of that money went to these Epic implementations. Does Epic, as a company itself, store all the patient data that is being used on each separate EMR at different hospitals around the country in one central location, or is each hospital responsible for the housing of that data? Each
hospital stores that data themselves in a warehouse or a system that is an Epic database. It is an almost impenetrable database, the way it's structured, and you will see most installations of Epic hold the data in Epic. Then they spend a lot of money taking the data out of Epic and into another data warehouse solution. And we have just bought Cogito, which is actually from Epic. So we build a mirror database for analytic purposes. Okay, so there's the EHR data, the EHR that you use, and the database that supports that. That's one package that we own here at UCSF and hold. We have another database which is sucking the data out to do analytics for research and so forth. And then there should be a backup database somewhere else. Okay, so Epic doesn't hold all the data itself.
Is there any downside that you see of, instead of having each of these individual institutions housing their data, have one gigantic just farm?
It would never happen. Never happen, not in this country. Because there are, people like to hold their own data. There's a lot of proprietary stuff. So the hospital here, like every hospital, holds the data very, very carefully because it gives you, data on market performance. They fight very hard for contracts. With the new healthcare approach, with the ACOs and so forth, the incentives are different. Maybe there's not so much gaming on negotiating prices, but that's business intelligence right there, and they don't want to let that out. Then there are universities that want to hold on to it because they want to let their researchers get at the data first. Then there's all these privacy issues, and and in this country, there's just no way we're going to have one giant database in the sky. It's just politically not something this country has any appetite for.
How do you encourage, with all these separate places, to allow communication between hospital systems?
So there's a model called federated databases, and that's a standard approach in computer science, and so matching back to health is important. And I think you see with Meaningful Use, you see with Blue Button and Direct, getting towards that model. I think that's a good approach. I think one of the things we need to do is shift away from a very enterprise-focused, doctor-focused system and start thinking about data as something that travels closely with the patient and not stuck to the hospital or the doctor, because there's a lot of data which is more personal, and that way we might be able to sort of break some of the logjam and break some of the silos. I think that's really important, but we've just started on that. Just started. And up to Peter to see when we want to.
No, let's go. I like this discussion.
In the back.
Just a quick question. We talk a lot about data, but how do we do quality control data too? I feel like, right now, garbage in, garbage out is kind of like how I see it. So.
Yes, and there's a lot of garbage.
Yeah.
Tremendous amount of. So I just asked that question, Michael. There will be a workshop in June called Data at UCSF, where we're planning right now a half-day, whole-day symposium to talk about data from Apex, UC Rex, which is the data warehouses from all 5 UC campuses, the Encore system. So we're going to show you, we're working right now on a dashboard where you can go and query, how many people over 50 who were seen in general medicine who have an A1C over 6 were on an ACE inhibitor. Okay, that kind of question we're trying to get to. And after all that, I said, well, what about the quality of the data? How do we know it's correct? And the answer is, well, we know that every time there's a piece of data that's transcribed from that EHR data warehouse to the analytic database, that translation is accurate. I said, that's not my question. We don't have a good plan. Yeah, but it's a common issue, it's a very common issue. We're still struggling because we spent so much money building the EHR and getting people to use it and shoving data into it. Okay, databases is really easy to shove data in a database, it's really hard to get it out meaningfully. And we're finding that. We spent all this money shoving the data into the database and now we're going, now what? Okay, so excellent question, we don't have as good an answer. And the answer may not be how do we ensure quality of what's coming out, how do we ensure quality going in? And that really, really begs the question of what do we really need to go in and what the heck this system is really for. Okay, because if you align those, then your data quality issues are going to be better. But I don't think we have a good approach to that quite yet. So,
This might be a very simple question, but I think for a lot of us, we spend the lion's share of our time chart reviewing and
Yeah.
actually going through and pulling
Yep.
specific information from
Yep.
Apex or whatever database. Is there a simpler way now I know for the unstructured data, it's probably very hard to get that pulled, but for some of the data which is actually coded, is there a way to get that in a kind of systematic way?
well, okay, so if it's coded, so is it coded, is it not? Is it coded to an appropriate target vocabulary, and is it coded with any accuracy? Okay, so those are three questions that, to the previous question, the answer is probably not, okay? Can you pull that out? You know what, I think that's what we're trying to get to, is a service where you can go and you say, I want to pull out this data, and someone will sit down with you and say, okay, well this data value, this coded value is highly reliable and it will make sense and we can pull it out for you. This one don't even bother, okay? That's called a data concierge. And we're struggling to figure out how we find those people, how we hire them, who they report to, and where this function sits. Now, this sounds really arcane, but we haven't figured out in this university where that function sits, because this is so new to us. Okay, so we're not a data enterprise, and we need to be a data enterprise. So we're moving towards where we'll have a service where you can go to someone and do that. Now, for the stuff,
And who will pay for it too?
huh?
Who pays for the concierge?
Well, right now the model is recharge. So, you come with that question, I'll say, well, you pay me and I'll tell you. Where are you going to get your money from? Right? So on the business side, this is non-trivial. The business side is saying, well, we'll recharge. Every investigator who wants something, it's value, so they're going to have to pay us because it's value. Okay, but where are we going to get our money from to do this? You need to do this so you can prepare a grant. You don't have money. Oh, you use your discretionary. What discretionary? So that's the question right now. It's a real question. Who's going to pay for this? Is this a basic function of the university or not? Who pays for it? Where is the value? Where does it accrue? And how do we do it so that, the Department of Medicine, being maybe richer than some other department, can have their own data concierge, but then, Puro Pediatrics doesn't, right? We shouldn't be doing that. So we're thinking campus-wide, how do we fund this? Who do we pay for it? Where do we hire these people? How do we train them? Okay, those are all issues. So we're getting that, and we're working towards that. For the non-coded data, for unstructured data, we should have somebody who does natural language processing. It's not that hard to extract, a question, did this person get a colonoscopy or not? Okay, really, okay. We should be able to do that, but it requires having somebody who has NLP experience and a pipeline, a service to do that. Once again, who's going to pay for that? We don't know. But the technology is there and the technology is possible. Not in a scaled way, but we can do it. Maybe one more question. If you still have it.
Oh yeah, so who's doing this well?
Who's doing it well?
Yeah.
Good question. I think Vanderbilt is doing it pretty well. Vanderbilt is headed by Bill Stead, who's been a long time advocate in this. He's also the vice chancellor of absolutely everything there, which really helps. Because you need senior level leadership. And I think you need senior level leadership to say that research and care really are on the same par as business needs. And that's a real, the more you get into the informatics, the more you realize it's a lot of policy and a lot of management, because the technology isn't the half of it. It's really what people really want. So I think Vanderbilt has it aligned. They have their genomics data, their biobanking data. They have invested in, in tens of programmers with the expertise that's needed. Harvard, in some places, some parts of it does pretty well. For the research universities, I would say those are the leading ones. For clinical research operations, it'd be Utah, Intermountain, Geisinger. Kaiser does a lot, Kaiser's good internally. For the academic medical centers, I'd say that we are probably a bit behind the